concept that we are going to discuss is synchronization. Okay. Synchronization. What is synchronization? How we can achieve this synchronization? And what are the different rules that are applicable while achieving synchronization? That we discuss. Okay. What is synchronization? Okay. Making a shared resource let's say making a shared resource, let's say, is nothing but synchronization. Let's consider like I have banking application where I'm creating the account. This I have a method which creates the account number, and the name of the method is create account number. Okay, the create account number, what is the message? Just we return a string which is account number. Now, this is the account number. Let's consider that I have a logic to create the account number in one class. Let's consider like I have a class okay, let me comment out this another thread. We'll use this later on. See, I created two threads and I started two threads. Now, just I am creating the account number. Okay. Just now what I am doing is I have a bank thread. To the bank thread, what I am giving. Okay, I am giving the bank manager. While creating the bank thread, I am assigning the bank manager. And using the manager, what I am doing is I am creating account number for the new account. Okay. So I have a class bank manager. let me have create account number. Okay, and let me have some 1000 statements here. Just I'm temporarily keeping some 1000 statement, but this contains the logic to create the account number. Understood what we have done? First, we have taken a bank manager class which has a method create account number and which has some 1000 executable statements in that. Okay, some 1000 executable statements are there in the create account number method, and that create account number method is being called from the run method of the thread, and the thread extends to that class, and the constructor I am sending the bank manager. Okay, and let me create a new bank manager class. And by passing the bank manager, I am creating two threads. T1, T2, and T1 dot start, T2 dot start. I am creating two threads, and two threads are sharing the same resource, bank manager. Okay, and these two threads are starting. Understood? See, there are two threads. What we have done is we have created a bank manager object. Okay, and we have two threads, P1, P2. P1 and P2 has the reference of bank manager. Both P1 and P2 has the reference of bank manager. Now, can we call this bank manager object as a shared resource of two threads? Yes, just because bank manager object is being used by both the threads. And using this T1 in the T1 run method as well as T2 run method, we are calling manager dot create from both from the run method what I am doing, just I am calling create account number. Understood? Understood what we have done now? Yes? Now let us see what happens. Cannot find symbol variable manager. Manager is not there. Sorry. Yes, I have declared the attribute manager. Okay, it was compiled. Let me go to the classes. Sorry, it is not capital T, small t. Oh, both are the same. So let me print the current thread then. Yes, I am printing the ID of the current thread. Okay. So let me go to compiler. Go to the classes, execute the application. So what happened? Okay, are these sequentially executed one after another, or are these two threads simultaneously executed? Are these two threads, okay, thread with ID 7 and thread with ID 8, are they executed sequentially one after another, or are they simultaneously executed? Parallelly executed, or once the execution of first thread is completed, then the second thread comes into picture. Simultaneously, those two threads are executed. So, there is a very chance that the account number of first thread will go to second and second thread will go to first. But if that is the case, will it be correct banking application? See, if let's consider like one account is from AP and one account is from Delhi. But both the applications, both account creations use the same account number. But based on the code, state code and the region code, the account number will be generated. So, if I give a account number for some person in AP with Delhi code, will it be a correct application? But there is a very chance that multiple threads interfere one another, just because multiple threads are sharing the same object. Okay, when multiple threads are sharing the same resource, or multiple threads are executing some shared code at the same time, if we want to make the shared resource thread safe, understood? If we want to make the shared resource thread safe, then we go for synchronization. Understood? This is eligible for synchronization just because account number will be unique. But it doesn't mean that all the things should be synchronized. What happens if synchronization is applied? Let us see. Then how we can apply synchronization? Means using a keyword synchronized. By using a keyword synchronized, we can apply the synchronization. We should synchronize the shared resource that we are using. How we can synchronize a shared resource means, okay, just by using a keyword synchronized. So, if you use the keyword synchronized before the method, let's see what happens. What happens? Is the output simultaneous or sequentially executed one thread after another thread? Once the purpose or once the execution of thread with ID 7 is completed, then only the thread with ID 8 comes to picture. Alright? Yes. Just because, okay, here the synchronization is being applied. Just because the synchronization is being applied, okay, that shared resource, this code became thread safe. Okay, means what is thread safe? What is thread safe? Means, okay, accessing a code piece by maximum only one thread at a time. What is thread safe activity means? Making a code piece to be accessed by maximum only one thread at a time. Making a code piece to be accessed. Making a code piece to be accessed by maximum one thread at a time. making a code piece to be accessed by maximum only one thread at a time is called as thread safe activity. And to achieve this thread safe activity, we go for synchronization. What, Charat? Okay. To achieve this thread safe activity, we go for synchronization. And how we can achieve synchronization in Java means using the keyword synchronized. Using the keyword synchronized. And the keyword synchronized can be used only for methods. Just because the business logic will be there only in methods. So, what happens if we create account number? Now, sequentially one after another the create account number will be executed. Okay? Only once the first thread account number creation is over. That means the first thread execution is over. Then only the second thread is coming into the picture. Okay? That's how it will behave. Okay? Just if you make a method as synchronized and if multiple threads are accessing that method, then multiple threads can access that method only one after another, not parallelly. If a method is synchronized, then multiple threads can access that method only one after another, not simultaneously. Okay, let me take a very simple example. I'm calling a method test1. I have my thread. So let me have a class shared. Let me give some 1000 statements here. So, if you want to see the differentiation in output of a thread, just give at least some 1000 statements. Then only we can get the correct difference. Okay? Let me remove the priority not required. Just what I'm doing is, I have a shared class, okay, and I have a method test1 in the shared class, and just I'm printing the current thread and the value of iteration, okay, and this shared class is shared by multiple threads. Now let me write a class and Understood what we have done? Just we are creating an object to the shared class, and by passing the same shared entity, okay, we are creating two threads to the same class. For my thread class, we are creating two objects. Okay, so first one object will be created. Now this object is an object to the class shared, and we are creating two threads, P1, P2. Okay, both are accessing the same shared object. Okay, just because I have given the same shared instance to both the threads, and both the threads are started. Now both the threads are starting to use the same shared instance, and both the threads are started simultaneously. The run methods will be executed. What I am doing? I am executing shared dot test1. So we have a test1 which is executed by both the threads, P1 as well as P2. Now, if one method is accessed by multiple threads, now in this case, the output will be sequential or simultaneous, parallel. Simultaneously, the test1 method will be executed by both the threads, just because it is not synchronized. If it is synchronized, then definitely symbol just let me create a constructor. Okay, so just I am creating my thread class object. Just compile successful. Okay, go to the classes, execute application. So thread 1 and thread 2. Okay, these two child threads are they sequentially or simultaneously executed? Simultaneously executed. Okay, so if they are simultaneously executed, now can I consider this method, the code in this method, as thread safe? No, this is not thread safe. If you want to apply thread safe, now we'll go for synchronized. Okay, first what you need to know is what is synchronization, why I should go for synchronization, and what is thread safe activity, why we need to implement the thread safe activity, and how we can apply synchronization. Nana class lo na tarvata chesana. How we can apply synchronization? Okay, how we can apply synchronization? Okay, and what are the different ways we can achieve synchronization? Okay, and what are the rules involved in synchronization? First of all, what is synchronization? Okay, class lo na tarvata chesana. What is synchronization means? Making a shared resource or making a shared code as thread safe. That's synchronization. Okay, what is thread safe? Okay, making a code piece to be accessed by maximum only one thread at a time. Why we need to make a code piece as thread safe? Let's consider like if the code piece contains some secured content, okay, and some unique content. If the code piece contains some unique content, let's consider like creation of account number, okay, creation of sequence number, which is a unique code piece. It should not be executed by multiple threads at a time. So that kind of code pieces, what we do, we make them as thread safe. So only maximum one thread will be accessing that code piece. Okay, that's how the synchronization will work. Okay, if you make the method as synchronized, the whole code in the method will become synchronized, so that if multiple threads are accessing that method, they can access that method only one after another, not simultaneously. Okay, so now let's consider that I have another method, test2. Okay, test1, test2. I am in test1 method and test2 method. Okay, so otherwise I will go first, second. Okay, the first method and second method. Now let's consider that the second method is not synchronized. Now let's consider like if the second method is not synchronized. Now if I access test2, what happens? Whether the output will become sequential or simultaneous? Definitely the output will be simultaneous. Just because this method is not synchronized. If this method is not synchronized, it is not thread safe. If it is not thread safe, obviously multiple threads access that method at the same time. So the output will be simultaneous. So simultaneously thread 0, thread 1 will be executed. Okay. So now can I call the code in test2 as thread safe? No. Can I call the code in thread1 as test1 as thread safe? Yes. Just because multiple threads cannot access the same test1 at the same time. Okay. So the code in the test1 can be considered to be thread safe. Okay. And how we can achieve this thread safe activity means by using the keyword synchronized. But what synchronized keyword makes the difference, and how the synchronized keyword makes the difference? Okay, how the synchronized keyword tells that this code should be thread safe. Okay, it means each and every object has a lock. Okay, for any object that is created in a Java application, that object will have a lock. Let's consider given this shared class object also will have a lock. Let's consider this is the lock of the shared class. Okay. Now a lock is required to access the object or to access the methods of the object. Okay. The lock is required only if we are accessing a synchronized method. Okay, each and every object has a lock, and the JVM requires. Okay, let's consider we are executing the statement inside the method of the object. Okay, now let's consider there is some other statement. Now, are all the statements executed through threads? Let's consider object has some 10 methods, and 10 methods has 10 statements. Only 100 statements. Now, can we execute even a single statement in those 100 statements without involvement of threads? Without involvement of threads, among those 100 statements, can we execute at least one statement? No, it's not possible. Any executable statement in Java should be executed through threads. So, any statement should follow the particular functions. Okay. Now, what my question is, okay, how this synchronized keyword makes the object as thread means. Okay. First, what did we do? First, I don't like for each and every object there is a log, and the JVM expects the log with the thread which executes a synchronized resource or a synchronized node. Let's consider I have thread 3.1 and thread 3.2. Okay? In order to execute a synchronized method test1, okay? The JVM expects, okay, the log of the object in which test 1 is present. Okay. Now let's consider like threads are not. Now is the lock of this object free? Is the lock of the object occupied or it is free? It is free. It's not occupied right now. Let's consider like thread 1 is started and thread 2 is started. Let's consider like thread 1 is first started. Let's consider like thread 1 is first started. T1 is first started. So, okay, and T1 is trying to execute test program. Now, what happens? Now, does T1 has a log of test 1? At first, T1 doesn't have a log of test 1. So, what happens? First, in order to execute a synchronized resource test 1, it should have a log. The thread should have a log of the object. So, is the log free? Now is the log free? Is the object log of the object free? Yes. So what happens? This thread 1 occupies the log. This thread 1 occupies the log of the object. The thread 1 occupies the log of the object and enters to the object and it accesses. Now let's consider that the same thing has to come. It comes into the picture and first to access test 1. Now, in order to access test 1, this requires the log. Yes or no? Definitely yes. It requires the log test because test 1 is a synchronized. Synchronized. But is the log of the object free or is it occupied? Since the log is already occupied, okay, the 2 should wait until the log is released. Okay? When the log is released means when the execution of the test method is completed by the thread. The thread one releases this log only when the execution of the method is completed. Until the execution of the method is completed, the thread one will not release the log. So that first thread one is completely executed, then thread 2 comes to the picture and thread 2 completely executed, then thread 3 comes to the picture. This is how, okay, synchronization or thread safe activity is being achieved by the code. Just make it not like, okay, only to access synchronized method, log is required. But if it is a non-synchronized method, log is not required to access that method. Okay? If it is a non-synchronized method, then no log is required to access that method, it can be accessed directly. But if the method is synchronized, then the log of the object is required to access that method. If the method is synchronized, then the log of the object is required to access that method. Test 1 is synchronized. So, log of the object is required to access that method. So, since the log of the object is required to access the method test1, okay, the output will be sequential. So, we go here, compile this application, go to the classes and execute. Okay, only when, okay, thread 0 completes, only when thread 0 completes the execution, then only thread 1 will come into the picture. First thread 0 will complete the execution, and only thread 1 comes into the picture. Just because there is a locking mechanism that is applied for synchronized methods. Okay. Now, is the same logging concept applied for non-synchronized methods? No. Just because lock is never required to access non-synchronized methods. So, non-synchronized methods are not guaranteed to be thread safe. So, see here, are they thread safe? See thread 0, thread 1, thread 0 and thread 1. These are not thread safe. Multiple threads can access the same method at the same time. Understood? For accessing non-synchronized methods, lock is not required. But to access synchronized methods, definitely the lock is required. Okay, that's the concept. So, for synchronized methods, only one thread can enter that method at a time. Multiple threads cannot access the same method at the same time. Okay, now let's consider like I have two threads. First thread, second thread. I had two thread classes. For the first thread class is first thread, and the second thread class is second thread. Understood? So let me create a object to first thread and second thread. Okay. Now I have two threads. Now both the threads are not accessing. Both the threads doesn't belong to the same class. Two threads belong to two different classes. Understood? Two threads belong to two different classes. One thread is of type first thread, second thread is of type second thread. Understood? The first thread T1 is of type first thread and T2 is of type second thread. Okay? Now let's consider like both have the same test one. Understood what we have done? First I am creating first thread. This is referred by T1. First what I am doing is I am creating a shared class object which has synchronized test one. Okay? And non-synchronized test one. Okay? Now T1 is of type first thread and T2 is of type second thread. Okay? The first thread we are executing test one. We are here the first thread we are executing test one. Second thread also we are executing test one. Are we executing the test one of the same object or different object? Are we executing the test one method of the same object or different object? Not asking the object of the same class or not. The same object or not. I am asking the question is whether we are accessing test one method of the same object or different object from the first thread and second thread. Same object. Just because we are passing the same class first thread as well as second thread. So we are accessing the same shares. So both test one as well as thread 2 are accessing the same shares. They are accessing the same method, test one. So now in this case, the output will be sequential or simultaneous. Understood the thing? Will the output be sequential or simultaneous? What my question or not? Okay? Now previously both the threads belong to the same class. Now one thread belongs to one class and another thread belongs to another class. Okay? But both the threads are accessing the same shared object. In this case, okay? Now the output will be sequential or simultaneous? Definitely sequential. It doesn't matter whether two threads belong to the same class or different class. Whether two threads belong to the same class or different class is a shared resource that defines the synchronization, not the classes of the thread class. Okay? Not the classes to which thread belongs, it is the shared resource that defines the synchronization. So, whether they belong to the same thread class or different thread class, if two threads are accessing the same resource, and if that is synchronized, definitely at maximum only one thread can access the shared resource. irrespective whether the threads belong to the same class or different class. Irrespective whether the threads belong to the same class or different class, those two threads accessing the same resource at the same shared resource at the same time. And if that shared resource is synchronized, definitely only one thread can access the shared resource. Understood? Irrespective whether they belong to the same thread class or different thread. Just let me set the name. F1. This one. First thread 1 and second thread 1. Okay? And let me try to print the name of the current thread. Okay? And F1 is the first thread object and S1 is the second thread object. So let me try to access those threads. So F1 and S1, which is sequential. One after another only the threads can execute the code. Okay? Now let's consider like the first thread is accessing the method test1 and second thread is accessing the method test2. Now just see what happens. Understood? The first thread is accessing the method test1. In the same case, just see on the board, just see that, okay, the first thread is accessing test1 and second thread is accessing test2. If that is the case, how could be the output? Will it be sequential or simultaneous? If thread 1 accessing the test1 and thread 2 accessing test2, whether the output will be sequential or simultaneous? Just see on the board, the same shared resource is being shared by T1 and T2. If T1 is accessing the test1 and T2 is accessing test2. Okay, these two are different methods. Okay, now the output will be the sequential or simultaneous. Sequential or simultaneous? Why do you think it is simultaneous if it is the same object? Why do you think it is simultaneous if it is the same object? The same object is being shared by T1 and T2. Okay? Let's consider like T1 is first getting started and if T1 is accessing the test1 method. Now, can T2 enter the object? Can T2 enter the shared object and access test2? See, let's consider that T1 is first started and T1 is currently executing test1 method. Can T2 enter the object and access test2 method? Yes or no? Yes. It can enter the object and access test2. Just because in order to access the test2, does it require a lock? No. Lock is not required to access test2. But lock is required to access test1. First thread is accessing test1 method, second thread is accessing test2 method. What happens? Let's consider like first thread 1 started. So thread 1 searches for the lock of first thread 1 started. Now in thread 1 what is it doing? It is accessing test2 method. In order to access the test1 method, is test1 method synchronized? Let's come to this here. Is test1 synchronized? Yes sir. Yes or no? Yes. The test one is synchronized. So in order to access the test one method, test one requires a log. Yes. So is the log free or is it occupied right now? Log is free. So the log will be occupied by P1 and it will go into the object and it will access. Now let's consider and the same time P2 is also shut. Now at the time of starting P2, is the log of the object free or is it occupied? Is it free or is it occupied? Log is already occupied. Okay? But even though the log is occupied, okay? Now test 2 is accessing P2, test 2. You know, test 2 is synchronized or non-synchronized? Non-synchronized. In order to access the non-synchronized method, log is not synchronized. So P2 also will access. So now in this case, what will be sequential or simultaneous? Definitely simultaneous. Just because test 2 is not synchronized. And to access test 2, thread 2 doesn't require a log. So if one thread is accessing a synchronized resource and another thread is accessing a non-synchronized resource, definitely it will be simultaneous. So simultaneously F1 and S1 are being executed. Okay? Just because one requires a log and another doesn't require a log. Okay? Now let's consider that test 1 and test 2 both are not synchronized. Both test 1 and test 2 are not synchronized. Now what will be simultaneous or sequential? Simultaneous. Just because to access test 1, P1 doesn't require a log, as well as to access test 2, P2 doesn't require a log. So both are simultaneous. Now let's consider that test 1 is synchronized. Okay, same time. Test 2 is also synchronized. Let's consider that both test 1 and test 2 are synchronized. And P1 is a thread of that first thread, and T2 is a thread of that second thread. P1 is of that first thread and T2 is of that second thread. These two are different thread objects, and P1 is accessing the test 1 of the shared object, and T2 is accessing the test 2 of the shared object. Now, what is the output? Will it be sequential or simultaneous? Will it be sequential or simultaneous? Okay. First, T1 is a thread and T2 is a thread. T1 is of thread first thread, T2 is of thread second thread. Okay. And both T1 and T2 have the same shared resource. Okay? But T1 is accessing test 1 method of the shared resource. T2 is accessing test 2 method of the shared resource. The same shared resource. And in this case, both test 1 as well as test 2 are synchronized. Then what happens? The output will be sequential or simultaneous?
It is different, both are actually different methods. So there is no problem. So it is simultaneously.
If both are different, since both are different methods and two threads are accessing two different methods, output is simultaneous. Will you all agree with that?
But how that will get the log? Because log is already sequential is
Answer his question. Ask the same question to you. Ask the same question.
And then that will acquire the log because it is easy one. It will really rely on the
Actually, for this, actually, we are different.
No, sir. He's asking the question. Answer. I'm not asking a question. He is having a doubt and he is asking a question. Answer it. Just answer the question 1 second.
Grade 1, require the law, and it is accepting the share. Then grade 2, are grade 2 concern. How you will get the law before getting my grade 1.
I mean, actually, the grid, what you do is the orders. The grid purpose, you have to include the code in the simultaneously. We are giving the test one in the orders, and test two in the orders. And just here, and even the code. If anyone is coming, suppose this is coming, and it is also asking the test one. Better than problem. And better we should take only one. But it's not a case.
What do you say? Just tell the amendment and tell the reason why you know that way. Why are you looking at me?
He's saying about that.
Don't tell me. No, just look at him. Tell your question. That why you don't agree as per my class. Tell the point that is specified by me and tell why you don't agree. Yeah.
Actually, you are saying the address. What address you are talking about?
Actually, what are we have to know one person which is very good.
You are only to access the law. Access there also.
And this was
You are access to different grade, you are access to different manner. But you require the same thing. You are going to require the law, then you will get to there. How will we get the
First, human is one thread and TV is one thread. Now let's select the object has a lock. Now at present, T2 and T1 and P2 are not started and object has a lock. Now is the lock of the object free? Yes. The lock of the object is, let's select C plus lock of the object. And this free right now. Okay? Now let's select first T2, T1 has no set. And T1 is accessing the method test1. So T1, you have to access test1, it should have the log of the object. So T1, why will you occupy the log? Okay, it will occupy the log and it will access the test1. Now let's select T2 comes to picture and T2 is accessing test2. Now for T2, in order to access test2, does it require the log of the object? Does it require the log of the object? Yes. You know, is the log of the object free? Is the log of the object free or is it occupied by any other thread? The log is already occupied by T1. So, until T1 releases the log, T2 cannot enter the object. Until T1 releases the log, T2 cannot enter the object. Okay? I specifically told that the log is for the object. Log is not for the method. Log is for the object. See, there are 10 synchronized methods in the same object. 10 logs will not be there. Only one log will be there. And to access any synchronized method, the thread should have that log. And log will be only one per object. Not one for a method. So, until T1 releases the log, T2 cannot enter the object. When T1 releases the log, when the execution of test1 is completely done. So, first completely the test1 executes test1 and then only test2 gets the log and goes into the test2 and executes the test2. So now we put between sequences, one after another. Just because the log is not at the method level, the log is there at the object level. And at the object level, only one log will be there. And even if there are 10 or 100 synchronized methods, only that object log should be occupied. So there are two synchronized methods accessed by two threads at the same time. Definitely the output will be sequential. Okay? Just because synchronization is not at the method level, like synchronization logs will not be at the method level. Method level logs will not be available. Only object level logs will be available. So once a thread accesses a synchronized method, no other thread can access even other synchronized methods of the same object. Understood? Just because the locking mechanism will be not at the method level, the locking mechanism will be at the object level. Understood, everybody? Understood?
Sir, there is a problem, sir, actually. And actually, rather good are there, and the whole method is not access. So,
Not all the methods. Only all the synchronized methods. See, if you lock the object, doesn't mean that we are not accessing, we are not making it eligible for accessing. We are locking only the synchronized method, but non-synchronized methods will be free access. There is no restriction, right? Okay. So only synchronized methods will be stuck there, but all the non-synchronized methods will be parallel with there, the performance will be there. And that's what I told. We don't keep synchronized for all the methods. We keep synchronized for methods those contain secure code, some unique code to be executed at a time. Let's have the creation of account number. Okay, creation of some sequence generation. Okay, that kind of code only will be synchronized. If we synchronize the whole code in the whole application, what happens? Performance will be drastically reduced. So we won't make the whole code as synchronized. We will make the methods those who contain the secure code as synchronized, the unique code as synchronized. The best example is unique number generation, like account number in case of banking application, policy number in case of insurance applications. Okay, those kind of things, those kind of code is only will be synchronized, not all the code. If you make all the code as synchronized, definitely it is the worst application. Understood? Only the secure code or the unique code should be synchronized. Understood?
yeah, and also, and we are synchronizing the both methods, but instead of that, we synchronize the statement and which is here.
That's what we discuss. Okay, it's called as a synchronized law. We are to discuss that. Okay. Now, this is how the synchronization works. Okay, by using synchronized keyword, and the synchronize is if a method is synchronized, and to access a synchronized method, definitely the log of the object is mandatory. Okay, so now let's consider that we have two shared objects. Now what happens? Just draw as a diagram, draw this example as a diagram and tell the output. What happens? Draw this output as, draw this application as a diagram, same like the diagram mentioned in the board, and tell the output. What happens? Both test 1 and test 2 are synchronized. Let me make both test 1 and test 2 as synchronized. Both test 1 and test 2 are synchronized. And from first thread I am calling test 1, second thread I am calling test 2. First thread I am calling test 1, second thread I am calling test 2. What, Sharad? Will it be sequential or simultaneous? Just see once again.
The 6 and 7 shifts actually they are referring to the same object.
System?
6 and 7. So x1 and x2 will refer the same object.
Is it? Why you are forgetting the basics at this point? Are they the same object or different object? What I told in the first class itself, I told each and every new with a constructor combination will create a new object. Now S1 and S2, are they referring to the same object or different object?
Actually, at the 6th line, x1 will point a object with a new shade object. But in the 7th line, again, we are creating another object. So S1 will cancel that reference and that will point towards the newly created object.
Why it will point to newly created object? See, S1 is the reference. Okay, if I do like this, then what happens? Since S1 is pointing to the newly created object, then existing reference will be demolished, and for the new object, S1 will refer. But am I doing that now? Just type it out and write newly so that you can understand it better in the future. Both T1 and T2 are synchronized. The test 1 and test 2 are synchronized. So what will be? What do you think it is simultaneous?
Because two objects, two different threads are pointing towards two different objects. So two objects have two different keys. So both keys are individually to the both threads. So they can act simultaneously, and the photo will be.
So the output will be simultaneous, definitely. Just because now what happens? S1 is pointing to one shared object. First, S1 is pointing to one shared object where it has S1 which is synchronized, S2 which is synchronized, right? And S2 is pointing to one object where S1 is synchronized, S2 is synchronized. Okay? So now what happens is, now thread 1 is accessing S1, thread 2 is accessing S2. Okay? Thread 1 is accessing S1, thread 2 is accessing S2. Now T1 is accessing the test 1 method, T2 is accessing test 2 method. Now, are they accessing the test 1 and test 2 of the same object or different objects? different objects. So even though the test 1 is synchronous here and test 2 is synchronous here, now to access test 1, it requires the lock is free, and if you occupy the lock, it another test 1. Now here also, here is the log. Now we will look for the log of first shared resource or the second shared resource. Second, just because T2 is accessing test 1. So when the second shared resource object is the same or different? Is it the same or different? Different. Okay. So go with this. But this is not much realistic. Okay. Shared means it's only one, it should be shared by multiple threads. It's not a realistic approach, but this will be asked in interview. What happens in this?
Sir, what is T2 trying to request step 1? What is T2 trying to request step 1?
Which one?
T2 thread
Try to refer this one.
disconnecting.
What happens? It will try to refer this one within the expected shared resource. Yes. Now is yes the log of S2 free? Yes. Whether it accesses S1 or S2 doesn't make any difference. Understood? Whether it tries to access the S1 or S2 doesn't make any difference just because it's for completely different object. This is looking for one object and this is looking for different object. So there is no combination for log between these thread and this thread. So there is no problem. Whether it access S1 or S2, whatever.
There is no thread.
What?
Then there is no thread.
There is not thread set. Obviously, when the same resource is same, then only thread set is expected. Here there is no requirement for thread set. Just because if two threads are accessing the same object, then only we require thread set activity. Now here, thread set activity is another requirement. Okay? Now, let's consider like test 1 is static. Test 1 is static and both are accessing test 1. Both thread 1 and thread 2 are accessing test 1. Now what happens is test 1 will not be there in the object. Where test 1 will be there? Where test 1 will be? Test 1 will be in the class area. In the class area, there will be test 1 which is synchronous. But test 1 is there in the class area and now test 1 has test 1 which is accessing this object and test 2 has test 2 which is accessing this object. Both of these have test 2 method which is synchronous. And there is a method test 1 which is synchronous and static. So all the static methods will be there in the class area. Okay? Now what happens? If both the methods, both the threads, T1 and T2 are accessing same test 1. Now, do they require a lock to enter? Do they require the object lock? Do they require the object lock to access test 1? Do they require the object lock to access test 1? No. They don't require the object lock to access the test 1. Now, in that case, the output will be sequential or simultaneous? Answer the question. They don't require the lock of the object to access test 1. Just because test 1 is not there in the object right now. Since they don't require the object of the the lock of the object of this test 1 state 1 or state 2. Now to access the test 1, object lock is not required just because test 1 is not there in the object right now. So in this case, will be the output sequential or simultaneous? Understood? Both the threads are accessing test 1 method. In this case, will the output be sequential or will it be simultaneous? Here both the threads are accessing the same test 1 method and test 1 is static. And to access the test 1 method, the lock of the object is not required. In this case, the output will be sequential or simultaneous.
The conflict will be arising. Conflict will
There is no problem. What do you think? Will the output be sequential or will it be simultaneous? But you may expect the output. I know that you'll expect the output to be simultaneous. But even to access the members of a class, even to access the synchronized members of a class level, in order to access the synchronized members at the class level means static members. To access the synchronized members at the class level, a separate lock is required, which is called as a class lock. To access the synchronized members at the object level, a lock is required, which is called as the object lock. To access the synchronized members at the class level, another lock is required, that is called as a class lock. Each and every class area will have its own lock, which is called as a class lock. Each and every class area has its own specific lock, which is called as a class lock. And the class lock is required for keyword to access test. So, for the whole class, there will be only one lock. For the whole class, there will be only one lock. So let's consider, just see here. Let's consider like first P1 has been started and P1 wants to access this door. So is test 1 static or not static? Static. Is test 1 synchronized? Yes or no? Test 1 is synchronized. So to access the synchronized method which is static, okay, the lock of the class is required. Now, is the lock of the class free? Yes. So the lock of the class will be occupied by test 1 to access test 2. Let's consider like thread 2 comes into the picture and thread 2 is accessing test 1 which is static. In order to access a synchronous method which is static, it requires a class lock. Now is the class lock free? Is the class lock free? No. So now can thread 2 enter into the class? Okay? Can thread 2 enter into test 1 until thread 1 releases the lock? Can thread 2 enter the test 1 until thread 1 releases the lock? Can thread 2 enter test 1 until thread 1 releases the lock? No. Thread 2 cannot enter test 1 until thread 1 releases the lock. Just because thread 1 is accessing the class lock, the class lock will be released by thread 1 only when the execution of test 1 is completed. So, only when thread 1 executes completes the execution of test 1, then only thread 2 can come into the picture and execute the test 1. Understood? So, lock can happen at two levels, the object level as well as the class level. For non-static synchronized methods, object lock is expected. But for static synchronized methods, class lock is expected. Understood? For non-static synchronized methods, object lock is expected, but for static synchronized methods, object lock is expected. Sorry, non-static synchronized methods, object lock is expected. Static synchronized methods, class lock is expected. Understood? So now let's consider that both S1 or S2 are differential resources. Let's consider like even test 2 is also static. Now even test 2 is also static. Now even test 2 is also static. Okay, so let's consider that test 2 is not there here, test 2 is there in the class area. Synchronized is 1, synchronized is 2. Okay, and so 1 is there, which is accessing this one. The 2 is there, which is accessing this 2. And the 1 is accessing this one. The 2 is accessing this 2. Let me make it the change. Thread 1 is accessing test 1 and thread 2 is accessing test 2. But both test 1 and test 2 are static methods inside the shared class. Inside the shared class, both test 1 as well as test 2 are static synchronized methods. Now in this case, what happens? Output will be sequential or will be sequential? Definitely the output will be sequential. One after another. Just because T1 is trying to access test 1 this time. Let's consider like first T1 starts first T1 is started. So for T1 to access test 1, it requires the log of the class. It requires the log of the class. So first it accesses the class log. Accesses the class log. Okay, and enters the class area and accesses the test 2. Now, T2 in order to access test 2, does it require the class log? T2 in order to access test 2, does it require the class log? Yes or no? Yes. But is the class log free or is it occupied by any other thread? It's already occupied. So, T2 cannot enter test 2 until T1 releases the test 2. Okay? T2 cannot enter test 2 until T1 releases the test 2. So, definitely the output will be sequential in this case. The output is sequential in this case. So, see here, once F1 is completed, then only S1 is coming to the picture. Understood? Now let's consider that both are having the same shared object. Both T1 and T2 are having the same shared object. And T1 is accessing test 1 and T2 is accessing test 2. Okay? T1 is accessing test 1, T2 is accessing test 2. Let's consider like T1, test 1 is synchronized, test 2 is not synchronized. Now let me make it clear. Test 1 is static, test 1 is static and test 2 is non-static. And it is synchronized. synchronized but non-static. Synchronized. Okay, and T1 is accessing S1 and S2 is accessing S1. But both S1 as well as S2 now they are not pointing to different objects, they are pointing to the same object. Okay, if you see here, I am making them to point to the same object. Now only one shared object is there, same shared object is shared by both first thread T1 and T2. In this case, what would be the both T1 and T2 both are accessing the same object, not different objects. And both the methods are synchronized. Both the methods are synchronized and both the threads are accessing the same object. Both the threads are accessing the same object. Both test1 as well as test2 both are synchronized. In this case, output will it be sequential or will it be simultaneous?
Very hard to understand. And because hard to understand, not hard to understand.
See, test1 is static, test2 is non-static. So test2 is like the object, test1 is like the class again. Output will be sequential or will it be simultaneous? Definitely it will be simultaneous. Let's consider like first thread 1 is coming to the picture and it is started, and in order to access test 1, thread 1 requires a class log or object log? Class log. Now is the class log free? Yes. So the class log will be occupied by test1. Now for thread 2 in order to access test 2, this is required class log? No. For thread 2 to access test 2, does it require class log? No. Does it not require log at all? Object log is required. Is the object log free? Yes. So this 2 will occupy the object log and will access the. So output here will be simultaneous. So, two synchronized methods are there, one is static and one is non-static. Then multiple threads can access those two methods at the same time. The interviewer can ask the same question as a theory. Let's consider like I have two synchronized methods in a class, one is non-static and one is static. And if two threads are accessing those two different methods, now the output will be are those two methods thread safe or not? Some of the interviewers will be asking as a theory like this. Let's consider like there are two methods. One is synchronized static and another one is synchronized and non-static. Two threads are accessing those methods. Now, are those methods thread safe or not? No. They are those two different methods can be accessed by two different threads at the same time. Just because one is synchronized static, another is synchronized and non-static. So, in that case, they can be simultaneously accessed. Okay? If static synchronized is there both for the both methods, then there will completion. Then there will complete for a lock. If both are static synchronized, or if both are non-static and synchronized, then only the computation for lock will be there and synchronization will be applied, or thread safe will be applied. Understood? If one is static and synchronized, another is non-static and synchronized, there will not be any computation for lock. Understood? That's how the synchronization will go. Okay? Make it a note like not all the methods will be made synchronized. Only with the methods that contain some unique code or some secure code will be synchronized. Okay? Thus, how we can achieve synchronization in Java using the synchronized keyword for the method. And just at the beginning of the class, some of the guys asked, why to make the whole method as synchronized when it's not supposed to be? This was a very good question. Why we should make the whole method as synchronized when it is not supposed to be? Only 2 or 3 statements of the method might be secured. The remaining code might not be secured. But if synchronization is there, okay, then will you agree that the performance will be degraded? Will you agree that the synchronization will degrade the performance? Yes. Definitely yes. That's why while discussing about string buffer, I told that string buffer is thread safe, but string buffer is not highly performing object. I told that, right? Did you remember the differences between string and string buffer? I told that string buffer is synchronized, but string buffer will give you the least performance, but security will be more for string buffer. That's what I told at the time. String buffer is said to be synchronized just because all the methods in the string buffer class are synchronized. That's why multiple threads cannot access the same string buffer at the same time. It's secured, but it gives the least performance. Anywhere, synchronization and performance are inverse proportional. Okay? If one increases, another decreases. Okay? So, if you want to compromise with performance, then we go for synchronization so that we can have some thread safe code. But we should not make the whole code as thread safe, which degrades the performance like anything. So, in a method, if we have 1000 lines and only 2 lines are secured, is it correct to make the whole method as secured? Understood my question? There are 1000 lines in a method where only 2 lines are secured. Then is it correct to make the whole method as secured? No, it's not at all correct to make the whole method as secured. For that purposes, okay, rather than implementing the synchronization by using the synchronized keyword for a method, we can even implement the synchronization by using a block inside the method, which is synchronized block. Rather than making the whole method as synchronized, what we can do is rather than making the whole method as synchronized, what we can do is we can make a specific statements. We can make some specific statements as synchronized. We can make some specific statements as synchronized. Let's consider like 0 to 100 to 1000 are non-synchronized and 0 to 100 are synchronized. Okay, 100 to 1000, these are not synchronized, but 0 to 100 are synchronized. So what we do is Let's consider like both the threads are accessing the same method, test 1. Let's consider like both the threads are using the same shared resource and both the threads are accessing the same method, test 1. Both are accessing the same method, test 1. Now in test 1, hello? Class lo phone chestuna. Okay, test 1 and test 2 are there, and in test 1 not the whole test 1 is synchronized, only the first 100 statements of test 1 are synchronized. Okay, now let me see how it happens. Sorry, synchronized will expect, okay, will expect the reference of the object on which synchronization should be applied. Synchronized block, this is called as a synchronized block. Synchronized keyword followed by parenthesis. In the parenthesis, we should give the reference of the object on which we are expecting synchronization. Synchronized block has a synchronized keyword followed by parenthesis. In this parenthesis, we should give the reference of the object on which we are expecting synchronization. And this is called as a mutex here. The value that we give or the reference that we give here in the synchronized block is called as mutex. The reference of the object that we give in the synchronized block is called as mutex.
Line could be synchronized, line could be continuous. It will not be continuous.
It depends upon the requirement. Okay, we cannot tell that which one is better and which one is worst. It depends upon the requirement. Okay, if only some statements are supposed to be synchronized, okay, then we will make that. Okay, it's not like synchronized block will be used anywhere, everywhere, and it's not at all used. It depends upon the requirement. If we want to make some specific statements as synchronized, okay. So just the synchronized block contains a synchronized keyword followed by parenthesis. Inside the parenthesis we will give the mutex. What is mutex means? The reference of the object that we need to apply synchronization. Okay, and the first 100 statements are synchronized and 100 to 1000 is not synchronized. Now let me see what happens. Go to the classes. You see here, let me see the first 100 statements, how it will be. If you see the first 100 statements, for the first 100 statements, okay, only when F1 releases the first 100 statements, okay, then only S1 is getting there. Understood? F1 and S1, these two are names of two different threads. When F1 releases the lock for the mutex, when F1 releases the lock for the mutex, then only S1 is coming to the picture. So that particular 100 statements are synchronized. Okay? Except the 100 statements, let's come to the next. After the 100 statements, okay, is it synchronized? After the 100 statements, S1, F1, S1, F1, S1, F1, S1, F1, S1. Is it synchronized after the 100 statement? At 100, up to 100 statement, up to the first for loop, we can expect that only one thread accesses that for loop at the time. But after that, we cannot expect that. Okay, after that, we cannot expect. Just because it's in a synchronized block and these particular statements are only synchronized. But in most of the scenarios, we use this synchronized block in the very first statements of the method. In general, we use this synchronized block in the very first statement or the very last statement of the method. But we can make any of the statements, any number of statements are synchronized by using a synchronized block. A synchronized block contains a synchronized keyword followed by a parenthesis. The parenthesis will give the mutex, which is the reference of the object on which we need to apply the synchronization. Okay? And here in the synchronization block, as any block in Java, it has opening brace and closing brace. Within that, we keep the statements that are supposed to be synchronized. Okay? Understood? And this will complete the part of synchronization. Okay? In the next class, we'll discuss how we can make use of wait, notify, and notify all. Okay? Next class will be tomorrow at the same time, 6.